Okay, welcome to Zaption Tour 2.4, solving equations with variables on both sides. The essential understanding in this lesson is to understand that if you're going to solve an equation with variables on both sides, you can use the properties of equality and inverse operations to write a series of simpler equivalent equations. So let me get started for you right here with an example, okay? This is box number 1 right here. It says, what is the solution to 5x plus 2 equals 2x plus 14? Notice that I have variables on both sides, right? I have a variable on the left and I have a variable on the right. So I'm going to use inverse operations and combine like terms. So I'm going to go ahead and subtract 2x from both sides, subtract 2x from both sides. So I'm seeing that 3x, because 5x minus 2x is 3x, plus 2 is now worth 14. Then I'm going to subtract 2 from both sides to get my variable by itself. So 3x is now worth 14 minus 2, of course, is 12. And then I'm going to go ahead and divide both sides by 3, the inverse operation. And so I'm left with that x is equal to 4. And if I was going to check this and wanted to see, I would just plug back in. 5 times 4 plus 2 is the same statement as 2 times 4 plus 14. Let's go ahead and see. 20 and 2, this makes 22. And 8 and 14 also make 22. So yep, that indeed does work. So there's our first example. For box number 2, I want you guys to try this one on your own. Okay, I want you to say, what is the solution to 7k plus 2 equals 4k minus 10? Okay, the correct answer is k is equal to negative 4. So the first thing that I did was I subtracted 4k from both sides. So let's call this step number 1, and that gave me 3k plus 2 is equal to negative 10. Then I subtracted 2 from both sides, call that step number 2. And that gave me 3k was negative 12, and then finally I divided by 3, so call it step 3, and I got k is equal to negative 4. So hopefully you're seeing that these are simpler equivalent equations that we are using to solve two-step equations. Box number 3 will be an example. And we're going to do this example using the distributive property. So notice I'm asked to solve 2 times 5x minus 1 equals 3 times x minus 11. So I'm going to go ahead and distribute. So 2 times 5x is going to give me 10x. And 2 times negative 1 is negative 2. And there's I'm going to use the distributive property and get 3x plus 33. So now I'm right where I was before, where I have variables on both sides. So I'm going to go ahead and bring the variables to one side by subtracting 3x from both sides of the equation. So 10x take away 3x, 7x minus 2 is equal to, those cancel out, 33. Now I'm going to add 2 to both sides. So I'm going to get 7x is now equal to 33 plus 2, of course, is 35. I'm going to use the inverse operation of division, and then I'm going to divide both sides by 7. So I'm going to see that x is now worth 35 divided by 5 is worth 5. And if I want to check and see how this will work, I would say, is 2 times 5 minus 1, is that the same thing as 3 times 5 plus 11? And it turns out that, yes, it is the same on both sides. Check it out and see. When you actually do this checkout, you get to see that both of these are worth 48. So yes, when you plug it back in, you realize that 48 is worth 48. So it does indeed work. Box number 4 here is the definition of what's known as an identity. Okay, the definition for an identity is an equation that is true for every single value of the variable. Every single value of the variable. I have 2 examples here down below. Okay, on the left-hand side over here, I have an example which is going to be an identity. And over here on the right-hand side, I have an example that's going to be no solution. I want you to take notice of the difference of the two. So if I write this down again, I would have 10x plus 12 is equal to, use the distributive property, right? And I would get another 10x and then plus 12. So you're noticing right away, I'm seeing the same thing on both sides of the equation, right? But if I were to keep going with this, and I subtracted 10x from both sides, subtract 10x from both sides, I would see that 12 is now worth, well, 12. Well, 12 equals 12 is a true statement, right? That is definitely a true statement. And you'll also notice that the variable has gone away. So it doesn't matter what number I put in for the variable, I'll always get a true statement. That's the definition of an identity. It's true for every possible value of the variable. Let's compare that one to this one on the right, okay? What I have been given here is 9m minus 4 is worth, well, 3m and 12m. That's 15m, right? 15m and then plus 5. Oh, sorry guys, this is supposed to be a negative 3m. Let me change that for you real quick. That's supposed to be a negative 3m. Okay? So now when I do this problem, I knew something wasn't right. Sorry about that, team. So I've got 9m minus 4 is now worth negative 3m plus 5 plus 12. So now let's combine like terms. Remember, that's a negative 3m. So here we go. 12 take away 3. So give me this. So I've got 9m minus 4 is now worth, so 12m take away 3m is worth 9m, and then I have plus 5. So I have an equivalent statement here, so I'm going to subtract 9m, and I'm going to subtract 9m, and I see that negative 4 is now equal to 5. Well, this is a false statement, all right? That's a false statement. So therefore, this equation up here has no solution. Okay, it has no solution. There is no value for m that would make both sides of the equation true. That's why there's no solution. Okay, here's box number 5. It's a you try. And I want you to go ahead and try to solve what is the solution to 3 times 4b minus 2 equals negative 6 plus 12b. Okay, here's the answer. Hopefully you got that this particular equation was an identity because we get a true statement that negative 6 equals negative 6. So therefore it's true for every single value that b could possibly be. We're going to get a true statement.